All right. So our next video is all about atomic structure. And so for atomic structure, we're going to talk a little bit about our current view of the atom, and then we'll just get into some of our basic atomic structure. And so right now, our current view of the atom is actually what we're seeing right here. So this gray ball. Now the center, that red center, is the nucleus. And then surrounding the entire center is what's called the electron cloud. Now, most of you guys, if I said, okay, like picture an atom, you're probably not picturing something quite this basic. You're probably picturing maybe something like what we call the Bohr model, where there's a bunch of rings going around the nucleus in the center. Or maybe you're picturing something like the little Jimmy Neutron logo, where you got your nucleus and then you got your orbiting rings going like this for the electrons. Now, in reality, our view has changed a whole lot over like the last 100 years. And that's kind of really what it comes down to. And so it's really a combination of, I'll call it both of these different models, the Bohr model and the Jimmy Neutron logo. And so that's something that you'll talk more about later on in the year, but let's kind of hit on some of these other basics. And so the first part is the nucleus. Now, the nucleus is always going to be located in the center of the atom, meaning it's the central part. Now, the nucleus overall itself is actually incredibly small compared to the rest of the atom itself. And so here inside the nucleus, even though it's small, it does contain two different particles. It contains protons and it contains the neutrons. Now, as it turns out, protons and neutrons are essentially the heavier parts of an atom. And so most of a masses or the mass of an atom actually comes from the nucleus itself. Aside from this, the other very important thing is that the nucleus is very, very small and very dense. So these are the important things with regard to the nucleus. Now let's talk about the outside, which is our electron cloud. Now the electron cloud, simply put, it just surrounds the nucleus. And within the electron cloud, obviously this is where all of our electrons are. And with all of these electrons, the other important thing with the idea of it being an electron cloud is that this is mostly empty space. And so the idea with the cloud is we have these atoms kind of floating around within that cloud, or these, sorry, not these atoms, these electrons floating around within the cloud. But electrons themselves are really, really, really small, but they just kind of float in and out through that whole space. Now, aside from this, let's talk a little bit more about our particles, or our important particles. And the three are the protons, neutrons, and electrons. So protons, usually we abbreviate as P plus. And the reason it's plus is because our protons have a positive charge. Then we have our neutrons. Now neutrons, we usually give this symbol N0. N for neutron, and then 0, indicating that neutrons themselves are a neutral charge, or they don't have a charge at all. And then finally, the last little bit is our electrons, and our way of writing electrons is E minus. And so if you had to guess, that does mean that our electrons are the negative charges. And so now that we've talked about protons, neutrons, electrons, let's get in a little bit further into atoms of our elements. Now, elements are made up of atoms of the same kind. Meaning, in terms of our elements, that means that when something is considered an element, all of the atoms are the same kind. Now, when we say the same kind, we mean the same number of protons in particular, which is something that we'll talk about in a few minutes. And so with each element, all elements have a couple different things. The first is the atomic number. Now, the atomic number is actually equal to the number of protons that that particular element has. And this is our way of defining the element. So this is how we separate what is, like, let's just say sodium versus what is chlorine versus what is calcium, is this idea of these different numbers of protons. And so if the number of the protons changes, that means that the identity of the element itself changes. And so that is a very, very important point when we're talking about looking at the numbers of protons. And so that does mean that generally atoms don't gain or lose or change the number of protons they have, because then you're talking about changing what the identity of that substance is. And so that's something that really doesn't happen unless you're talking about like radioactivity. But normally that just isn't something that happens. Now, if an element is neutral, meaning it doesn't have a charge, that means that the number of protons is actually equal to the number of electrons. And so now let's kind of take a look at our sample here. And so our sample here is just a sodium. And so this is kind of a snippet of what we actually see on the periodic table. And so a lot of times, for example, your periodic table, it's going to have 11 on the top, Na, then it's going to have the word sodium underneath there, and then this 22.90. So let's talk about what all of these numbers actually mean. So the first one at the top, this is the atomic number, which, remember, is also overall the identity of the substance, and it indicates the number of protons that that element has. Now this other one, this one down here, 22.990, this is the atomic mass. And so we'll talk or define what atomic mass is in a few minutes, but that's just what those numbers actually are telling us in each box on the periodic table. So with that in mind, let's kind of take our look at sodium. So what's the atomic number? 11. How many protons does it have? 11. And how many electrons does a neutral atom of sodium have? Remember, if it's neutral, the protons and the neutrons should be equal to each other. All right. And so now with this idea, let's start talking about some of the masses and the atomic mass and where that comes from. So the first thing is that all individual atoms have this thing called the mass number. Now the mass number is equal to the number of protons plus the number of neutrons. And so the idea is, as we're changing the number of neutrons, this is what's changing the mass of the atom. Now, as we're talking about changing the mass of the atom, remember, changing protons changes the identity, changing neutrons changes the mass, and in a minute, we'll talk about what changing the electrons actually means. But with this, if we have an element such as sodium, if the mass number is protons plus neutrons, keep in mind on the periodic table, it says 22.990, right? But if that's supposed to be the mass, why is it 0.990? Because we can't have 0.99 of a proton or 0.99 of a neutron. We either have a whole one or we don't have a whole one. And so this is where the idea of atomic mass comes in. And so atomic mass is a little bit different. This is the weighted average of all of the masses of an isotope for an element. And so when we say it's the weighted average, just kind of like how grades can be calculated as like 20% is like a quiz, 20% is tests, and 40% is homework. And I guess I'm still missing another 20%. Let's say 20% is participation. So that idea of like homework being worth more than a quiz, for example, that's a weighted average. And so as it turns out, that's the same way that we get our atomic masses. And so when we're talking about the atomic mass, this is actually the mass that you find on the periodic table. And so the idea or the result of an average of all the masses, or the result of an average of the masses of all the isotopes of that element. And so with atomic mass, it takes into account all of the isotopes for individual elements. Now let's talk about what actually an isotope is. And so an isotope is an atom of an element that has a different number of neutrons. Now remember, if it has a different number of neutrons, that means that it's a different mass. And so the idea is, let's just use chlorine there. So see how it's chlorine 35.453? That means that as they got this number, that means that there's isotopes of chlorine that have a mass of something like 33. Then there's some that have a mass of like 35. And then there's some other ones that have a mass of like 36. And so that's essentially how they look at calculating the, or they use those three different isotope masses and then calculate the atomic mass. So let's look a little bit more about chlorine here. And as we're looking at chlorine on the periodic table, we got a couple questions. What's the atomic number? 17. Remember, that's this number on top. How many protons does it have? Remember, protons matches the atomic number, so it's 17. Then we have how many electrons does a neutral atom of chlorine have? Now remember, if it's neutral, that does mean that it has to be the same as the number of protons, so 17 again. And then finally, if it has a mass number of 35, how many neutrons does it have? Well, remember, if mass is equal to our protons plus our neutrons, that means that if our mass is 35, we have 35 equals our 17 protons plus our neutrons. And so that means that if we subtracted, we would get our number of neutrons is equal to 18. So it has 18 neutrons. And so now that we've talked about this idea of looking at masses and the atomic numbers and symbols and all this other stuff, let's talk about our way of showing it. And it's through what we use, or what we call isotopic notation or symbol notation. Now, our way of writing symbol notation is to write the symbol that you'd see on the periodic table of that element. And then there's three spots where we write numbers. The first one is we write in the top left of that number. This is the atom's mass. And so, or our mass number. And so that should always be a whole number. So it's like what we did earlier, or what we saw earlier with the mass number of 35. So that would be up here. Then let's say that we have that bottom number. That bottom number always tells us the atomic number, meaning it's telling us the number of protons. And then finally, in our example here, we don't have anything, but in this upper right-hand corner, that would be where we would label the charge. Now remember, if there isn't anything listed there, that means that it's going to be neutral. So just something to kind of keep in mind. And so now let's look at some examples here. And so let's consider the ion bromine or bromide. And so if we're talking about bromide, our first step should be to go through and look at what the atomic number is. And so as we're looking at the periodic table, it's on the far right side. And we see that the atomic number is 35. So how many protons does it have? Well, if the atomic number is 35, it should have 35 protons. Okay, next up, how many electrons does it have? Okay, well, remember electrons are the negative charge, right? And so if it's a Br minus, it's got a -1 charge, which means that it has one extra electron compared to the number of protons. So if it's got 35 protons and we have one extra electron, which gives it that -1 charge, that means that we have 36 electrons. And then finally, the last little part, how many neutrons? Well, this part is a little bit tricky because I should have given you a mass, but let's say the mass is equal to 80. Well, if the mass number is equal to 80, that means that it's 80 equals our 35 protons plus our unknown number of neutrons. And let's just kind of do some quick math here. And we should get that our number of neutrons has to be 45. All right, so that's it for this example. Now, before we move on, let's actually write this in isotopic notation, just so you guys are used to seeing it. And so our step would be, we write it as Br, then the mass goes in the top left-hand corner. So the mass we said was 80. So that means 80 would be on top. Then below it, remember, is the atomic number or the number of protons. So in this case, it's 35. And then finally, the last part is the fact that it's Br minus, which means we should have our -1 charge in the top right corner. All right, so now that we've talked all about this, let's put this whole thing together. And so for this, you'll probably want a periodic table just to kind of help you guys out with this. Now, let's kind of go through a couple keys as you guys are pulling out your periodic table. Remember, the number of protons and the atomic number should be the same. Then, remember, our mass number should be protons plus neutrons. Now, we didn't actually we talked a little bit about charge in our last example, but I didn't really give you guys an equation. If you're an equation person, feel free to use this. The charge is equal to the protons, or the number of protons you have, minus the number of electrons you have. And that'll always give you the charge. And then finally, our last question, did that element gain or lose any electrons? All right, well, with that in mind, let's kind of go through and talk about how we would fill in this particular chart. So first up, let's just start off with the information that we know. We know there's 26 protons, 24 electrons, and it's got a mass of 56. Well, remember, if there's 26 protons, that means the atomic number is 26. All right, that was pretty easy so far, right? Now we can look at the periodic table and see what element is element number 26. And there it is, Fe, or iron. So under symbol, we can write Fe. Then our next step should be looking at our number of neutrons. Now, since we're given a mass, we can solve for our number of neutrons by using the number of protons as well. So in this case, it's going to be 56 minus the 26 protons is equal to our number of neutrons. And so when we do that, we get 30. All right, so next up, our last missing box for this one is the charge. And so let's kind of look back. If we have 2 extra protons compared to our electrons, that means that it's going to be a +2 charge. Now you can also use that equation as protons minus neutrons, which would give you also +2. Now remember, for charges, you can't just write 2. You do have to label it as plus or minus. So just something to keep in mind as you guys are labeling these charges. And then since the charge is +2 there, under our symbol over here, we also have to label it with this +2. So it's not just Fe, but it's Fe +2, or iron 2. And then finally, it told us we lost electrons, which makes sense because if it was neutral, we would have 26 electrons. But since it's not neutral, that means that we had to gain or lose electrons, and in this case, we lost some. All right, let's look at our next example here. So our next example, it gives us the atomic number 29. Now, automatically, that means our number of protons is 29. And then, if we go and look at the periodic table and find element number 29, oh, there it is. It's copper. So we can label that with our symbol here. All right, now let's kind of look at the other information that we have. And for this one, we're missing the electrons and the neutrons, but we're given the mass number and the charge. Now, if the charge is labeled as neutral, remember that does mean that under our number of electrons, we should have the same number of electrons as we do protons. So that should also be 29. Then for our number of neutrons, this would be similar to how we solved our last one. It would be our protons plus neutrons equals our mass, or if we skip our step of algebra, 64 minus 29 should give us our number of neutrons, which in this case is 35 neutrons. And then finally, to answer that last question, did we gain or lose electrons? Well, if it's neutral, that means no, we didn't gain or lose electrons. So for this, we can write it as like Na, since it doesn't really apply. All right, and so for our last one here, in this case, we're only given the number of electrons, the number of neutrons, and the charge. So we're not given a number of protons or an atomic number. But because we know the charge is +1 and the number of electrons is 36, that does mean that we actually know the number of protons. Because if it's +1 and we have 36 electrons, that means that we have 1 extra proton, meaning we have 37 protons, which means our atomic number is 37, which also means our element in this case is rubidium. So we'll put Rb, and then don't forget, since it's got a +1 charge, we should label +1 there. And now finally, for our last 2 missing boxes, we got the mass number, which should be, remember, protons plus neutrons. So in this case, it's 37 plus 48, which would give us 85. And then finally, the last part, gaining or losing electrons. Well, in this case, because it's a positive charge, that does mean we lost electrons. All right, so that's it for this video. I'll see you guys on the next one.